Hey YouTube, how you doing? Happy to see you all here. Thanks for joining the live show, either live or coming in and watching afterwards. Hi Dylan.
Hey, how's it going, Michael?
Hey, it's good to have you here on the
Yeah,
podcast.
thanks.
Yeah, you ready to kick this thing off?
Yeah, let's do it. Let's do it. Very happy to be here.
Dylan, welcome to Talk Python to me.
Yes, thank you. I am a fan, have listened to a lot of episodes and big podcast fan, so I'm happy to be on here.
Thanks. Yeah, I'm sure you are. Your specialty is in the realm of turning voice into words. So
Yeah,
I
that's
bet
right.
you do a lot of studying of media like podcasts or videos and so on, right?
Yeah, it's actually funny. So I started the company, I started Assembly like 4 years ago, and there was this one audio file that I always used to test our speech recognition models on. It was this Al Gore TED Talk from like 2007, I think. And I've almost memorized like parts of that TED Talk because I've just tested it so many times. It's actually still part of our end-to-end test suite. It's in there. It's like a legacy kind of founder thing that's like
Yeah.
in the code
Cool.
still. Yeah. So it is kind of funny, especially now that so we're like 30 people at the company, and I'll see some of the newer engineers like writing tests around like that Al Gore file still, and it makes me laugh because that's like there's no real reason I picked that. It was just something easy that came to me.
Yeah, you're getting
Yeah.
started. I just got to grab some audio. Here's something, right?
Yeah, exactly.
Yeah.
So yeah, definitely have also listened to like a ton of podcasts, and I was with we just started like releasing models for different languages, and I was with someone from our team last week, and I heard this like phone call and this like foreign language, people like screaming on this. I was like, what are you listening to? And it is funny, as an audio company, you get sometimes data from customers, and it's like you have to like listen to it. Yeah.
Yeah, I bet there's some interesting stories in there for sure.
Yeah. Well, we're very privacy conscious, so
Yeah, of
not,
course.
not too many, but
Yeah, there was
yeah.
just on The Verge, there was just a an article about a different speech to text company. I don't know, have you seen this, that there was some suspicious stuff going on? Here, let me see if I can
No,
find it. I
no.
think uh what was it called? It was Otter,
Interesting.
Otter.ai, which I'm not
Yeah.
asking you to speak on them, but um, this journalists
Interesting.
Otter.ai scare is a reminder that cloud transcription isn't completely private. Um, but yeah, so we can talk a little
What
bit.
happened here?
Yeah, we'll get it. Basically, there was a conversation about Uyghurs in China or something like that,
Yeah.
and then they unprompted reached out to the person who was in the conversation and said, "Could you tell us the nature of why you had to speak about this?"
No way.
They're like, "What?"
That is crazy.
Yeah,
That
they're
is
like,
crazy.
we're a little concerned about why you're
It's
interested
kind
in
of
the
like
content of our
there's
conversation.
there's a lot of that like suspicion around, there's some like conspiracy theories right around like, oh, does your phone like listen
Yeah,
to you while you're around, and does it ambiently listen to you and then use that data to remarket to you? And I was talking to someone about this recently. I know nothing about the location based advertising world, but sometimes I'll be talking about something, and then I'll see ads for it on my phone, or if I'm on Instagram or something. And someone told me it's probably more based on like the location that you're in and the other data
yeah.
that they have about you.
You were at your friend's house. Your friend just searched for that, then told you about it,
Exactly. So
and
you're
now
likely
the
to probably
yeah,
also, yeah, exactly.
it's probably. I think the reality of that is that it's actually more terrifying than if they were just listening to you. That
Yes.
they can piece together this shadow reality of you that matches reality so well.
Yep. Yeah. Like your friend just bought this thing and you went over, and then so maybe you're interested in this thing because you're
Yeah, they probably told
probably,
you about it or something, right?
yeah, yeah. It is really crazy. It is really crazy. I haven't paid too much attention to all the changes that are happening around. Like, I know I listened to some podcast, I think on the Wall Street Journal, about like the big change that Google's making around that tracking, and how a lot of people are up in arms about that. And it was saying something how like they're going to have, and sorry if I'm derailing, whatever plan we had for
You're
a
derailing
conversation
in a way
there.
that I'm like super passionate about because it's so crazy. But yeah,
Yeah,
we'll go
yeah.
too deep. But yeah, it's so interesting.
They said that there's, I'm probably butchering this, but something how like for each user, they're just gonna have like 6 like categories about you, and then one of them is gonna be randomly inserted as to somehow anonymize your profile. And I just thought, yeah, it was super weird to hear about how
Yeah.
they're doing that and like what the meeting was internally that came up with that idea, you know? So I'm like, well, let's just throw a random category on there. Um, yeah, I don't
It's
know.
so you know, my without going too far into this, my thoughts are we're faced or we're presented with a false dichotomy. Either you can have horrible, creepy tracking, advertising, shadow things like we talked about,
Yeah.
or you can let the creators and the sites that make the services you love die. And those
Mhm.
are not the two. There are more choices than two in this world, right?
Yeah.
For example, you could have some kind of ad that is related to what is on the page rather than who is coming to the page, right? You don't necessarily
Right.
have to retarget me. Like, for example,
Right.
right here on this podcast, I'm going to tell people about, I'm not sure without looking at the schedule what the advertisers are for this episode, but I am going to tell people about that. And it is exactly related to the content of this show.
Yep.
It's not that I found out that, you know, Sarah from Illinois did this Google search and visited this page. So now we're going to show, like, no, it's, there's so many sites like this, this one here on The Verge. You could have ads for Assembly AI, and it would be, maybe you don't actually want on this one, but you know, like things like this.
Right. Right.
You could, it would be totally reasonable to put an ad for speech to text companies on there that requires no targeting and no evil shadow companies. And there's, you know, like we can go on and on, but there are many ways like that, right? That don't require this false dichotomy that is being presented to us. So hopefully we don't end up with either of those, because I don't think those are the best options or the only options.
Yeah, it's weird how that's kind of how things developed, you know,
Yeah.
to where we are now. Yeah, but I agree with you. There's probably a lot we could
Everyone's
unravel
looking for
here.
like, okay, well, if we do retargeting, we can get 2% better returns. And like, you know, no one's worried about, well, what happens to society?
Yeah, that's actually what I was going to say. It's all about the kind of high growth like society that we have where you need to maximize growth and maximize returns. And I mean, I understand this acutely. Like I'm, you know, the CEO of a startup, so I get it. But yeah, it's when it's like growth over everything, you end up with things like what you said, like, oh, it improves it our returns 2%, so let's do this. But you
Yeah,
don't think about what the trade-offs will be. Yeah.
absolutely. All right. Well, thanks for that diversion. That was great.
Yeah. Yeah.
But let's, before we get beyond it, let me just get your background real quick. How do you get into programming? And I'm going to mix it up a little, and machine learning. And this,
Yeah.
yeah,
Yeah, definitely. Do you want the long story or the short story? How many minutes
intermediate,
do I have? Intermediate.
intermediate.
Great. So the intermediate story is that I started a company when I was in college, just like a college startup thing. And at the time was very limited in my programming knowledge. I had done some basic like HTML when I was a kid. I was really into like Counter-Strike and Call of Duty
Oh
and
yeah.
yeah, I would like sell up like private servers. I don't know how I got into this, but well, I like rented these servers and I would like remote Windows desktop into them and set up like private Counter-Strike servers and then sell those and set up like a basic website for it with HTML and CSS and my brother was super into computers, so it was always kind of into computers. And then in college, got into startups, and I think like programming and startups are like really connected. So through that, learned how to code, learned how to program, started attending Python meetups in Washington, D.C., where I went to school. And that's how I met Matt Mackay, it was a mutual
Yeah.
connection. So attended a bunch of meetups, learned how to program, and then got really into it. But I think what I found myself more interested in was the like more like meaty programming problems, more like I guess like algorithm type problems, and that kind
Yeah.
of naturally led me to like machine learning and NLP, and then kind of just like took off from there because I found that I was really interested in machine learning and like different NLP problems.
Those are obviously the really hard ones. It's so
Yeah, yeah.
especially probably when was this that you were doing it? When or the
This is maybe like 2013,
okay.
2014. Yeah,
So
so
kind of the early days of when that was
yeah,
becoming real, right? I remember feeling like all this AI and text to speech or speech to text rather type of stuff was very much like fusion, like 30 years out, always 30. Like it's going
yeah,
to come
yeah,
eventually, but people are doing weird stuff in Lisp and it doesn't seem to be doing much of anything at all,
yeah.
and then
I've
all of a
played around with
sudden,
some Perl NLP, some like Perl scripts,
yeah.
Yeah,
And then all of a sudden we end up with like amazing speech to text. We end up with self-driving cars, like something clicked and it all came to
yeah,
life.
yeah. It's kind of crazy, especially over the last couple of years. What's I think what's really interesting is that a lot of the advances in like self-driving cars and NLP and speech to text, they're all based on similar machine learning algorithms. So, like the transformer, right, which is like a really popular type of neural network that came out, was initially applied towards like just NLP, like text language modeling related tasks. Now that's shown to be super powerful for speech as well. Um, Whereas classical machine learning, there were still these underlying algorithms like support vector machines or other types of underlying algorithms, but a lot of the work was around like the data. And so how can you extract better features for this type of data? And you had to be like, I remember when I was getting into speech recognition, I bought this speech recognition like textbook, and this is a while ago, and it was around like really understanding like phonemes and how different things are spoken and how the human speech is spoken. And now you don't need to know about that. You just get a bunch of audio data and you train these like big neural networks and they figure that
Right.
out.
You wanted to understand British accents and American accents, you just give
Give
it
it
a
more
mix, right?
data.
Yeah.
Yeah, exactly. So, but it is crazy to see where things have gotten over the last couple of years, in particular. Yeah. So, um, when I was starting out, neural networks were there, but they're a lot more basic, and you didn't have like there's a lot more compute resources now, more mature libraries like TensorFlow and PyTorch. Um, I think I went to like one of the first TensorFlow meetups that they had, or not meetups, like developer days or whatever, down at the Google conference. So it's like so new still. Yeah, it's so new.
Yeah, it's easy to forget just a while
It
ago
is. It is.
that all
Yeah.
this stuff didn't even exist, right?
Yeah. Absolutely.
So, you mentioned assembly AI. That's what you're doing
Yes.
these days, right?
Yeah. So I am the founder of a company called Assembly AI. We create APIs that can automatically transcribe and understand audio data. So we have APIs for automatic speech to text of audio files, live audio streams, and then APIs that can also summarize audio content, do content moderation on top of audio content, detect topics, what we call like audio intelligence APIs. And so we have a lot of startups and enterprises using our APIs to build the way we call it, like applications on top of audio data, whether it's like content moderation of a social platform or speeding up workflows like I'm sure you have, where you take a podcast recording and transcribe it so you can make it more shareable, or
Yeah,
extract pieces of it to make it more shareable. Yeah.
exactly. Yeah. Basically, for me, it's a CLI command that runs Python against your API, against a remote MP3 file, and then magic outcome
That's the
comes out the other
great
side.
thing about podcast hosts that are also programmers. Like I've talked to a
Exactly.
few, and they're all like, there's a bunch that are non-programmers and they use these different services. But every podcast host that I've talked to that's a programmer, they have their own like CLIs and
Oh
Python
yeah.
scripts that they're running, and yeah, yeah,
Yeah, there's a whole series of just CLIs and
I
other
know,
commands to do the workflow. I
yeah,
do want to just
fun.
give a quick statement disclaimer. So if you go
Yes,
over to the transcripts, or possibly, I suspect if you listen to the beginning of this episode, it'll say that it's sponsored by Assembly AI. this episode is not part of that sponsorship. This is just you and I got to know each other. You're doing interesting stuff. You've been on some other shows that I've heard that the conversation was interesting. So invited you on. Right. Thank you for sponsoring the show. But just to point out, this is not actually part of that. But with the
Yes.
transcripts that we do have on the show, the last year or so are basically generated from you guys, which is pretty cool.
Yep. And we don't even need to talk about assembly that much on this podcast. We can talk about other things.
Yeah. So one of the things I want to talk about, and maybe what's on the screen here gives a little bit of a hint of being TensorFlow, is why do you think Python is popular for machine learning startups in general? Like, I feel that I'm not as deep in that space as you, but from looking in from the outside, I guess I would say it feels very much like Python is the primary way at which a lot of this machine learning stuff is done.
Yeah, it's a good point. So like why that is, I think outside of machine learning, even I think Python's just such a popular language because it's so easy to build with compared to like PHP or C# and like even JavaScript. Like when I learned to code, I started with Python because the syntax was easy to understand. There were a lot of good resources. And then there's kind of this like snowball effect where more people know Python, so there's more tutorials about Python, there's more libraries about Python, and it's just more popular of a language. Yeah, this Insight Sui pulling this up.
Yeah, if people, I mean, I've
this a lot,
right? But if you pull up the Stack Overflow trends for the most popular programming languages, there's only one that is going dramatically up out of, what is this, 10 languages or something? And it's just
so much more popular. Yeah,
it is. It's so interesting how it's really sort of taken off. And it wasn't, back in when you got started and when I got started back in this general area of 2012, 2011.
Was it number one language?
It was the number one then was, what is that?
C#.
But you got to keep in mind, this is a little bit of a historical bias of Stack Overflow. Stack Overflow was started by Jeff Atwood and Joel Spolsky, who came out of the .NET space. And so when they created, like, its initial traction was in C# and VB. But over time, clearly, it's become like where programmers go, obviously. So, take that a bit with a grain of salt. But that was the number one back in the early days.
Another founder legacy.
Yes, exactly. So I agree that it's absolutely generally popular, and I think there's some interesting reasons for that. It's just so approachable, but it's not a toy, right? A lot of approachable languages are toy languages, and a lot of non-toy languages are hard to approach.
That's a good point. Like for me, it was very easy to get started with Python, and I actually I taught myself how to program. I went to college. I studied like economics, so like did not study college or programming in college, computer science. And the first language I started to try to learn was PHP, and I bought this like huge PHP textbook and made it halfway through, and I was like, "What is going on?" And I gave up. And then tried again with Python later, and it was so much easier. And then I also wonder how much of this is like for the machine learning libraries in specific. Like you have these macro trends where a lot of the data science boot camps that have been so popular, like there's like scikit-learn. I know we have a tab up there. There's like NumPy, and I forget what NLTK is one of the popular NLP libraries. So there are a lot of libraries in Python in the early like when I was getting into NLP, I worked a lot with NLTK and like SciPy and scikit-learn and NumPy, and I think a lot of work was done around there. And so people that were doing data science or doing some type of machine learning were already in Python, and then now you have like PyTorch and TensorFlow, and it's just like kind of cemented. Like, okay, the machine learning libraries today, the popular ones, you work with them in Python.
Yeah, you want to give us your thoughts on those? We've got TensorFlow and PyTorch, and probably scikit-learn as well. Those are the traditional ones. We've got some newer ones like Hugging Face, which
they're a cool company.
Yeah, maybe give us a survey of how you see the ML space, the libraries that people might choose from. Yeah.
So when we started the company, everything was in TensorFlow, and I think
when was that?
It's back in like late 2017.
Okay.
Late 2017. everything was in TensorFlow. And actually, I don't know what year PyTorch came out. I don't even know if it was out back then, or maybe it was like just internally at
Yeah, it's pretty
Facebook.
new. Yeah. Mhm.
Yeah. So TensorFlow was definitely, they got started early. I think their docs and like the framework just got kind of complicated over the years. And then they sort of rebooted with like TensorFlow 2.0, and then there was like Keras that was popular. It kind of got pulled in. Now I think like, so we switched everything over to PyTorch in the last like year or two. A big reason for that was that, and we actually put out this article on our blog comparing like PyTorch and TensorFlow, and we have this chart where we show like the percentage of papers that are released where the code for the paper is in PyTorch versus TensorFlow. And it's a huge, huge difference. Like most of the latest research gets implemented. Oh, yeah, here it is. Like if you go down to one of like, so this is, yeah, Hugging Face. Can you keep going? Yeah, research papers. Yeah, go up to that one.
Okay.
So it shows like the fraction of papers. And so what we're showing here for the people that are listening is like a graph that shows the percentage of papers that are built using PyTorch versus TensorFlow over time.
Yeah, when you started, it was, what is this, 6-7%
yeah,
PyTorch,
like
and the balance being TensorFlow when you started your company, and now it's 75% PyTorch. That's a very huge, large change. Yeah,
really dramatic change. You know, if PyTorch was a company, it'd be like probably raising a lot of money. But I think one of the reasons we picked PyTorch is because a lot of the newer research was being implemented in PyTorch first. There were examples in PyTorch, and so it was easier to get. They have it on it's their tagline, to quote them, like from research to production, right? Like it was easier to get more exotic, advanced neural networks into production and like actually start training models with those different types of layers or operations or loss functions that were released in these different papers. So we started using PyTorch, and we kind of haven't looked back.
Well, if you're tracking all the research and trying to build a cutting edge startup around ML, you don't want to wait for this to make its way to other frameworks. Like you want to just grab it and go. So if that's where the research is being done, that helps a lot, right?
Right. Exactly. Yeah. Exactly. You can just get up and running a lot faster with the newer research. And so most companies that I talk to now, they're all using PyTorch. I think PyTorch is definitely like the more popular framework. There's some new ones coming out that have people excited, but still, like from what I can sense, PyTorch is, if someone was going to get started today, I would tell them to start with PyTorch.
Yeah. Okay.
I think TensorFlow
who runs PyTorch?
Yeah, go ahead.
Sorry, who runs PyTorch?
It was released by Facebook, right?
Yeah. And then TensorFlow, that's Google, right?
Google, yeah. Yeah. And I think Google's tried to like tie TensorFlow into their like cloud ML products. So like train your models on Google Cloud and like use their TPUs in the cloud. And there's probably some like business cases behind that, but I feel like it may have made the developer experience worse because it's trying to like give back to Google. Whereas, you know, PyTorch isn't trying to like get you to train your models on Facebook Cloud or something.
Yeah. What's the story with Hugging Face?
People probably wouldn't use Facebook Cloud if that existed nowadays, you know?
Yeah.
I don't know if you'd want to host your data in Meta Cloud. Meta Cloud.
Yeah, Meta Cloud. You can only do it in VR. What's the story with Hugging Face?
So Hugging Face is a cool, so this is a company actually, and they have, it's kind of hard to even explain. It's like, you can basically get access to a bunch of different pre-trained models really quickly through Hugging Face. And so if you want to, a lot of work around NLP now is like, how familiar are you with like self-supervised learning or like face models for NLP? How familiar with that?
Somewhat. So the idea is to have a general model and then apply some sort of transfer learning to build up a more specialized one without training from scratch. Is that
exactly? Yeah. And that general model is really just trained to like learn representations of the data. So it's not even really trained like with our particular like NLP task. It's just like trained to learn representations of data. And then with those representations that it learns, you can then say like, okay, I'm going to train you towards this specific task with some labeled data in a supervised manner. And so there are some really popular open source like base models, foundation models, like BERT is one. There's a bunch of others, but you can easily get like load up BERT basically and fine tune it on your data with Hugging Face. So if you're trying to get a model up and running quickly in like the NLP, like the text domain, you can do that pretty easily with Hugging Face.
Okay.
And yeah,
Interesting.
so it's less like if you want to like build your own neural network from scratch, like inputs to outputs, implement your own loss function, all that, you would do that in PyTorch. If you want to try to just like quickly fine tune BERT for a specific task that you're trying to solve, you could still go like the PyTorch route, but it would just be faster to go with Hugging Face. So they've seen a lot of adoption there. And then scikit-learn is kind of like the old school library that's been around forever with like
the OG, yeah, for sure.
OG, yeah. Like if you want to do stuff with like support vector machines or random forest or like k-nearest neighbors, this scikit-learn is probably still really popular in that for those different use cases.
I do think that I hear the scikit-learn being used quite a bit still.
Yeah.
Maybe in the research, the academic. If you go take a course on it, probably there's a lot of stuff on this, I would guess.
Yeah, like there's a lot of times where, you don't really need to build a neural network. There's parts of our stack that are like basic machine learning, like statistical models. And if you can get away with it, it's a lot easier to train and you don't need as much data and it's easier to deploy. So like a lot of like recommendation type models and sometimes SVMs are just like good enough. SVM support vector machines are just good enough for a task that you might want to have. So
for a lightweight Netflix recommendation or YouTube recommendation, not like the high end stuff that I'm sure they're actually doing. Something like that.
Yeah.
That kind of recommendation engine. Yeah.
Something basic. Yeah. Although I actually am kind of underwhelmed with like the Netflix and YouTube recommendations are very good. Netflix recommendations and like Prime recommendations, I'm kind of underwhelmed by. You would think that
I agree.
Yeah. It's still so hard to find things to watch sometimes on those platforms.
It is, and YouTube interestingly seems to have like an end. So if you scroll down through YouTube like 10 pages, it'll start showing you like, well, it seems like we're out of options. Here we'll show you 10 from this one channel, and then we'll just kind of stop. You're like, I know you got a lot of videos. You could just keep recommending stuff. I'm pretty sure if you would keep recommending, there's stuff down here, but. Yeah, I agree. It's interesting.
I feel like it's gotten better too. Like my YouTube consumption has really picked up over the last year, I would say. Their recommendation algorithms, and I don't know if it's just more content being created or maybe it's just like a personal thing for me, but and there was some thing on Hacker News too about like YouTube comments that like one of the founders of Stripe posted are like generally very positive, and like there's really good comments on YouTube too. So they've definitely also come up with ways to classify comments as being high value or not, and then put those up top. And nowadays, those models are definitely used with something like BERT, some big neural networks, some transformer, because those neural networks, they're so much better at understanding context. And like SVMs, you have to still, for a lot of these classical machine learning approaches, like feed it hand labeled data and but the neural networks, they're really good for those language tasks now.
Yeah, absolutely. Christopher out in the audience has a question that's kind of interesting. Does it make sense to start with scikit-learn if, for example, you're trying to predict when a production machine is not out of tolerance yet is trending to be?
Is that like
if you were like monitoring like a data center for maybe VMs?
Like your RAM or like memory is going high, or like some statistic is like predictive that this VM will
failure is coming. Yeah, something like
failure is coming. Yeah, and the question was, is it SVM or scikit-learn good to start with? Yeah, I would actually probably say that's where you want to go with something like scikit-learn, because there's probably very clear-cut patterns I would say if you're unsure of what the pattern is, then a neural network is good because the neural network can, in theory, like you're feeding it raw data and it's
Yeah.
learning the pattern. But if you know what the pattern is, like, okay, like there's probably like these signals that if a human was just sitting there looking at it all day would be able to tell this system is probably going to go down, then you just can train a SVM or some type of classical machine learning model with scikit-learn to be able to do those predictions with pretty high accuracy. And then you've got a super lightweight model. You don't need much training data to train it because you're not trying to build something that's like super generalizable to like all systems or like all AWS instances. It's probably something unique to your system. But I would say that's kind of where the difference is. And then it's a lot easier too, because if you're trying to build like a neural net, it's like, well, what type, how many layers, what, kind of like optimization schedule, like learning rate. There's all these hyperparameters and things you have to figure out. You still have to do that too for classical machine learning to a degree, but if your problem's not that difficult, it's not as, like fancy nowadays, but it gets the job done.
Yeah. I suspect you could come up with some predictors and then like monitor them in this model, whereas opposed to here's an image that is a breast scan. Does it have cancer or not? Right. Like
Exactly.
we don't even really know what we're looking for, but there probably is a pattern that could be, pulled out by a neural network.
Exactly. Yeah. That's a great point. And, like we're trying to build some predictive scaling for our API right now because, one of the problems with or challenges of a startup that's doing machine learning in production is, we deploy like hundreds of GPUs and thousands of CPU cores into production every day at peak load. And you have to be able to scale to demand. And if you overscale at that like size, then there's just huge costs that come with that. If you underscale, there's bad performance for end users. And so we've done a ton of work around like auto scaling and trying to optimize models in production and things like that. And now we're trying to do some predictive scaling. And for that, for example, we probably do something super simple with like scikit-learn. We wouldn't do a neural net for that.
Yeah, the scaling sounds like solving basically a similar issue.
Yeah.
As understanding failure, right?
Yeah, exactly.
The lack of scaling sometimes is kind of the result is failure. So they're somewhat related together. All right, you talked about like running stuff in production, and there's obviously two aspects for machine learning companies and startups and teams and products that are very different than, say, the kind of stuff I do, right? Like I've got APIs that are running, we've got mobile apps, we've got people taking the courses, but all of that stuff, there is like it's always the same, right? It's we put stuff up and people will use it and consume it and so on. But for you all, you've got the training and almost the R&D side of things that you've got to worry about working on and scaling. And then you've got the productionizing. So maybe tell us a little bit about how what do you guys use for training?
Parts.
Maybe start with the training side.
Yeah, the training side, it's basically like impossible to use the big clouds for that because it would just be prohibitively expensive, at least for what we do. So we train like these huge neural nets for speech recognition and different NLP tasks. And, we're training them across like 48, 64 GPUs, like really powerful GPUs.
Yeah, I've got the GeForce 3090, which is a beast up here. Like, what do you know? What kind you're using?
Yeah, so we use a lot of V100s, like A100s, and we rent. Basically, what we do is we rent dedicated machines from a provider, and each machine we're able to like pick the specs that we want, like how many GPUs, what cards, how much RAM, what kind of CPU we want on there. So we're able to pick the specs that we want. And we found that that's been the best way to do it because big clouds, if you're running like dozens of GPU, like of the most expensive types of GPUs for like weeks on end, you could do that if you had like one training run you wanted to do. But a lot of times you have to train a model halfway through, it doesn't work well, you have to restart, or it finishes training and the results are not that good and you learn something, so you have to go back and start over. And now what we're doing is buying a bunch of our own compute. Like my dream is to have some closet somewhere with just like tons of GPUs and like our own like mini data center for the R&D, because
Yeah.
if things go down, like when you're training a model, you checkpoint it as you go. So if your program crashes or your server crashes, like you can resume training. Whereas like for production workloads, we use AWS for that because things can't go down. And I don't think we'd want to take on our own competency of like hosting our own production infrastructure. But for the
Right.
R&D stuff, we are looking into just buying a ton versus renting, because it'd be a lot more cost efficient, and you can, instead of basically like paying each year for the same compute, you just like buy it once and then you just pay for the electricity and server hosting costs and maintenance costs that come with that. Yeah.
Yeah. Maybe find a big office building and offer to heat it for free in the winter by just running it on the inside.
Yeah. There's this like, you can run like NVIDIA SMI. I don't know if you play around with GPUs at all, but like you can see what the temperature is of the GPU. And like sometimes, I remember a while ago when I was training some of these models, I would just like look at what the temperature is during training, and they get so hot, and these data centers have to have all these special cooling infrastructure to keep the machines down.
Yeah,
pretty
to the extent that
environmentally
some of them,
unfriendly.
to the extent that people are creating underwater data center like nodes and putting them down there and just letting the ocean be the heat sink. Yeah,
Yeah, maybe
crazy.
we can buy some land in like Antarctica and put our stuff there. That's where like the GitHub like the Arctic Code thing. I forget what it's called.
Yeah, the Arctic Code Vault. Yes.
Yeah. So we could do something like that for our GPUs when we get bigger. That's the dream. That's like my burnout dream. So we train. I think we have somewhere like maybe like 200, like GPUs that we use just for R&D and training, and we're getting a lot more. Because you don't want to be. A lot of times there's like scheduling bottlenecks. So two researchers want to run a model and need a bunch of compute to be able to do that, and they're both good ideas. You don't want to have to like wait 4 weeks for someone to run their model because compute is taken. So we're trying to unblock those scheduling conflicts by just getting more compute. And for the production side, we deploy everything in AWS right now, and onto like smaller GPUs, because a lot of our models do inference on GPU still. Some of our models do inference on CPU.
Oh, interesting. To evaluate the stuff, it still uses GPUs even after the models are created. Okay.
Correct. Yeah. I mean, we could run it on CPU, but it's just not as parallelizable as running it on GPUs. There's a lot of work that we could probably do to get it really efficient, so that we're running it on like as few CPU cores as possible. But one of the problems is like almost like every like 3 to 4 months, we're like throwing out the current neural network architecture and using a different one that is giving us better results. Like sometimes we'll make the model bigger, or there'll be a small tweak in the model architecture that yields better results. But a lot of times it's like, okay, we've kind of iterated within this architecture as much as we can, and now to get the next accuracy bump, we have to go to a new architecture. We're undergoing that right now. We released one of our like newer speech recognition models. We released, I think, like 3 months ago, and the results are really good. But now we have one that is looking a lot better, and it'd be like a completely different architecture. And so it's just that trade-off of, do you spend a bunch of time optimizing the current model that you have and trying to like prune the neural network and do all these optimizations to get it really small, or do you just spend that research effort and that energy focused on finding the next accuracy gain? And because we're trying to win customers and grow our revenue, it's just, all right, let's just focus on the next model. And when we have a big enough team, or when we can focus on it, we'll work on making the models smaller and more compute efficient and less costly to run. But right now, like our speech recognition model that does inference on a GPU. There's a couple of our like NLP related models, like our content moderation model that does inference on a GPU. And then there's like our automatic punctuation and casing restoration model, like that runs on a CPU because that's not as compute intense. And so it really varies. Yeah.
But it's pretty interesting.
Sorry, go ahead.
I was gonna say, it's pretty interesting to think about how you're optimizing the software stack and the algorithms and the libraries and whatnot, when you're not doing something that's changing so quickly, if it's working, you can kind of just leave it alone, right? Like
Right.
I've got
Right.
some APIs. I think they're built either in Pyramid or Flask. Sure, it'd be nicer to rebuild them in Fast API, but they're working fine. I'm just like, I have no reason to touch them.
Right.
So
Right.
I don't, there's not a huge step jump I'm going to take. They're not under extreme load or anything, right?
Yeah.
But in your world, right, there's so much innovation happening around the models that you do have to think about that. So how do you work that trade-off? How do you like, well, could we get more out of what we've got, or should we abandon it and start over, right? Because it's something, it
Yeah.
is nice to have a very polished and well-known thing as well.
Definitely. And every time we throw out our architecture and implement a new architecture, you've now got to figure out how to run that architecture at scale. And you don't want to have any hiccups for your current customers or users of your API, which sometimes happens because these models are so big that you can't just write this like monolith service that like sits on a GPU and does everything. Like you have to break it up into a bunch of component parts to let it so that you can run it efficiently at scale. So there's like 8, 9 microservices for like a single model because you break out like, okay, all these different parts and try to get it running really efficiently in parallel. But it does beg the question of like, how do you build good CI/CD workflows and good DevOps workflows to get models into production quickly? And this is something that we're working on right now and trying to solve. Like, because a lot of times we have better models, and we sit on them for like 2-3 weeks because we have to get them into staging. We have to do load testing, see does anything with scaling have to change because the model profile is different. Are there any weird edge cases that we didn't check or see during testing? So it slows down the rate of development because you have it's hard to do CI/CD. It's not like you just run these tests, the code works, go. There's like compute profile changes that happen, and so maybe you need a different instance type, or you need to
right. It uses less CPU,
yeah,
but way more RAM. So if you actually deploy it, it's going to
exactly.
crash or something. Okay.
Exactly. And then doing that at scale, you have to, like profile that and do load testing. And so really we're trying to figure out how to get these models into production faster. And I think the whole like ML ops world is so in its infancy, around things like that. And it's a lot of work. Yeah, it's a lot of work. So for us, the trade-off though is always like, our customers and developers, they just want better results and always more accurate results. And so we just always are working on pushing our models, making them more accurate. If we can iterate within a current architecture, great. Like sometimes you can just make the model bigger or make a small change and then you get a lot of accuracy improvements. And it's just like what we call like a drop-in update where no code changes. It's just literally like the model that you're loading is just different. And then it's just more accurate.
Right. That's easy. Yeah.
That's the dream, it's just a drop in. But that's maybe like 30% of updates. Like the other 70% are, okay, you've got a new architecture or it's got a pretty different compute profile. So it uses a lot more RAM or it's a lot slower to load in the beginning. So we need to scale earlier because instances come online later and become healthy later. So there's all these like things you have to think about. Yeah.
The whole DevOps side of this sounds way more interesting and involved than I first thought.
Yeah. It's painful too. I mean, we're like, I can't explain how many like graphs we have in Datadog, just like monitoring things all day and like how luckily I don't have to work on that anymore. That was very stressful when I was like owning the infrastructure. Now we have people that are better at it than me. We had like 2 DevOps people start on Monday, but like DevOps is a huge piece of this.
Yeah, that's quite interesting. I do want to just circle back to one real quick thing. You talked about buying your own GPUs for training, and people might out there be thinking like, who would want to go and get their own hardware in the day of AWS, Linode, whatever, right? Like it just seems crazy. But there's certainly circumstances. Like here's an example that I recently thought about. So there's a place called Mac Stadium where you can get Macs in the cloud. Hey, how cool, right? So maybe you want to have like something you could do with extra things. And well, what does it cost? Well, for a Mac Mini M1, it's $132 a month.
You think is that high or low?
Well, the whole device, if you were to buy it, costs $700, you know?
Yeah.
And
That's
I suspect that even though the GPUs are expensive, there's probably something where like if you really utilize it extensively, it
right
actually makes
to
it
buy it.
stops making sense in ways that people might not expect.
Yeah, that to buy it, you mean, right? Like it
Yeah.
stops making sense to rent it. Yeah,
It
that's what
stopped
we're
making
facing.
sense to rent it in the cloud. Yeah.
Yeah, I mean, we spend a crazy amount of money renting GPUs in the cloud, and it's like, okay, if we had a bunch of money to make a, capex purchase, right? Like just shell out a bunch of money to buy a bunch of hardware up front, it'd be so much better in the long run because it is similar to the example you made about like if you don't have a lot of cash, then and you're only going to use a Mac for a couple months,
Right. You need it for 2 weeks, then it doesn't make sense to buy it. Yeah. You just,
great.
you pay the $100 and you're good to go.
Right. Or if you don't have like 2K and
Yeah. Yep.
then you just rent it, and it's like, if you don't have the money to buy a house, you rent an apartment, right? Like things like that. So uh um there are definitely benefits. And I think for most models, you don't need crazy compute. Like you could get away with like you could buy a desktop device that has like 2 GPUs, or you could rent a dedicated machine, or still do it on AWS if you're using like 1 or 2 GPUs, and it wouldn't be insane. So if you're just starting out, all those options are fine. Um, but if you're trying to do like big models and or train a bunch in parallel, you need more compute. And yeah, you could like definitely doesn't make sense to use the big clouds for that. There's a bunch of dedicated providers that you can rent like dedicated machines from and just pay a monthly fee regardless of how much you use it. And it's a lot more efficient for like companies to do that.
Interesting. Give me your thoughts on sort of CapEx versus OpEx for ML startups rather than, I don't know, it's some other SaaS service that doesn't have such computational stuff. Being CapEx being you got to
Yeah.
buy a whole bunch of machines and GPUs and stuff versus OpEx of like, oh, it's going to cost this much to run it in the cloud. Like, I feel like
It's
things
crazy.
are more possible because you can get the stuff in the cloud, prove an idea, and then get investors without going, well, let's go to friends and family and get 250,000 for GPUs. And if it doesn't work, we'll just do Bitcoin.
Yeah. Definitely. I mean, we started in the cloud, right? So like first models we trained were K80s on K80s, and AWS took like a month to train.
Wow.
Yeah, it was terrible. So we started in the cloud, and then now that we're fortunate to have like more investment in the company, we can make these capex purchases. But yeah, I mean, the operating expenses of running an ML startup are also like crazy. Like payroll and payroll and like AWS are our biggest expenses because you run so much compute, and it's super expensive. And what I talk about and what we talk about is like there's nothing fundamental about what we're doing that makes that the case. It's just goes back to that point of like, do you spend a couple months optimizing your models, bringing compute costs down, or do you just focus on the new architecture and kind of pay your way to get to the future, like this growth versus and we're like a venture backed company, so like there's expectations around our growth and all that. So we just focus on like, okay, let's just get to the next milestone and not focus too much on like bringing those costs down because there's the opportunity cost of doing that. But eventually we'll have to.
It's a little bit of the ML equivalent of sort of the growth. You can lose money to just grab users.
Grow,
equivalent, right? But this is the sort of gain capabilities, right?
It is. It is 100%.
And then you'll figure out how to do it efficiently once you kind of find your way. Okay.
And I'll give you like a tangible example. I mean, like we've been adding a lot of customers and developers on the API, and there's always like new scaling problems that come up. And sometimes we're just like, look, let's just scale the whole system up. It's going to be inefficient. There's going to be waste, but like, let's scale it up, and then we'll like fine tune the auto scaling to bring it down over time. Versus like having to step into like a more perfect auto scaling scenario that wouldn't cost as much, but there'd be bumps along the way. And so we just like scaled everything up recently to buy us time to go work on figuring out how to improve some of these like auto
Interesting.
scaling. Yeah,
Yeah, you could spend 2 weeks trying to figure out the right way to go to production, or you could spend just more money, get it to work,
exactly.
and then because you might not be sure with the like the multiple month life cycle of some of these
Right,
things. Is this
right,
actually going to be the way we want to stick with? So let's not spend 2 weeks optimizing it first.
right. Um,
Very interesting.
and I mean, like, look, not every company can make that decision. Like, if you are bootstrapped or you're trying to get off the ground, which like a lot of companies are, you do have to make those. Like, you can't just pay your way to the future.
Yeah, yeah. And I'm a
So
big fan of bootstrapped
yeah,
companies
yeah, me too,
and
me
finding
too.
your way. I don't think that necessarily just set a ton of money on fire is the
Right,
only
I
way
agree.
forward. But if you have backers already, then they would prefer you to move faster, I suspect.
Correct. Yeah, correct. Like I always like I always was self-conscious about our, operating costs as an ML company because they're high compared to other SaaS companies
Yeah,
where you don't have heavy compute. But the investors we work with, they get that like, okay, this isn't um there's nothing like that fundamental about this that requires those costs to be high. You just have to spend time on bringing them down. And
yeah,
there's like a clear path. It's not like Uber where it's like the path to bring costs down or like self-driving cars because
yeah,
it's expensive to employ humans. That's like, so far down the road.
yeah,
Um, but for us, it's like, okay, we need to just spend 3 months making these models more efficient, and they'll run a lot cheaper. But it's yeah, that
yeah.
trade-off. But I love bootstrap companies too. I mean, it's just a
Something
different way to
special
do it.
about like you're actually making a profit. And you're actually you have customers and people
No
paying
one
for
to answer
something.
to. Yeah,
Yeah, yeah, and
yeah,
the freedom for sure. So
yeah.
you probably saw me mess around with the screen here to pull up this Raspberry Pi thing. There's a question out in the audience that says, "Could you do this kind of stuff on a Raspberry Pi?" And like a standard Raspberry Pi, I suspect absolutely no. But have you ever
Yeah.
seen that there are water cooled Raspberry Pi clusters? Are you aware
Whoa,
of
I
these
have
things?
not seen that. That is crazy.
Is that insane?
That's
So
insane. What kind of compute are they getting on that?
you know what? It's pretty comparable to a MacBook Pro on this, and they've
That's
got like
crazy.
8 water cooled Raspberry Pis in a cluster. And it's really an amazing device. But if you look back at you sort of consider it like a single PC with a basic NVIDIA card or a MacBook Pro or something like that. Like that's still pretty far from what you guys need. Like how many GPUs did you say you were using to train your models? It's
It's like
100.
yeah, like 64 for the bigger ones. Yeah, in parallel. Yeah,
Yeah, and these are not small GPUs. So
I
I
don't think
suspect
that would work.
I'm gonna maybe throw it out there for you and say probably no. Maybe for the scikit-learn type stuff, but not for what you're doing. Not the
Yeah, not
TensorFlow.
for training, but you could do inference on a Raspberry Pi. Like you
Yeah,
could squeeze a model down super tiny, like what they do to get some models onto your phones, and run that on a Raspberry Pi. You get the model small enough. The accuracy might not be great, but like you could do it.
yeah,
There's a lot of stuff happening around the edge. Like I think a lot of the
yeah.
Siri,
The edge compute, the sort of ML on device type stuff.
yep, like a lot of the speech recognition on your phone now happens on device. Um,
Yeah,
yeah, and
yeah.
not in the
Sort of
cloud.
related to this, like the new M1 chips
Right,
and even the chips in the Apple phones before then come with like neural engines built in, like multi-core neural engines. Interesting for
right.
edge stuff again, but not really gonna let you do like the training and stuff like that, right?
Yeah, yeah. Like I haven't done much iOS development, but I know there's like SDKs now to kind of like get your neural networks like on device and make use of these, um, like the hardware on the phone. And definitely, if you're trying to deploy your stuff on the edge, there's a lot more resources available to you
Yeah.
now.
It's a
And
really
yeah,
good experience because having, you speak to your assistant or you do something and it says thinking like, okay, well that I don't want that. Like I'll just go do it if I gotta wait 10 seconds.
right, right.
Um, yeah. So
But it happens immediately, and there's the privacy aspect too. Of
yeah, absolutely. The
yeah,
privacy is great. Yeah.
yeah, like the wake word on the like I don't know if you know this, but like the wake words like on the Alexa device, like they happen local. That runs locally. Although
see.
I've heard that when you say Alexa, they verify it in the cloud with a more powerful model.
Interesting.
Because sometimes it'll trigger and then shut off. I don't know if you've ever seen that happen.
Yeah,
Um,
it'll spin around and go, no, that wasn't right.
yeah, exactly. I think what's happening is that they're sending like the wake word to the cloud to verify, like, did you actually say Alexa? Probably if the
Yeah.
local models below some certain confidence level, it sends it up to the cloud, and then the cloud verifies, like, yes, start processing. But it is much faster from a latency perspective. Although with 5G, I don't know if like like
Yeah.
mobile internet is so much it's faster now.
It's getting pretty crazy. Yeah,
Yeah.
absolutely.
Yeah, sometimes I'll be somewhere where my Wi-Fi is slow and I'll just tether my phone and it's like
Yeah.
faster,
If I'm
Yeah.
not at my house, I usually do that. If I go to a coffee shop or an airport, I'm like, there's a very low chance that the Wi-Fi here is better than my 5G tethered.
Yeah,
So I'm just
yeah,
gonna do that. Yeah.
exactly.
Chuck Woody out in the audience has a real interesting question, I think, that you can speak to because you're in this space right now, living it. What do investors look at when considering an AI startup, or maybe, an AI startup, not just specifically speech to text?
Yeah, it's a good question. I think it really depends on, like, are you building like a vertical application that makes use of AI? So are you building some like, you know, like call center optimization software where there's like AI under the hood, but you're using it to power this like business use case versus are you building some like infrastructure AI company like we're building APIs for speech to text, or if you're building a company that's exposing like APIs for NLP or different types of tasks. I think it varies what they look at. I am not an expert in like fundraising or AI startups. I want to make that very clear. Like, so maybe don't take my advice too
Yeah, but you've
seriously.
done it successfully, which is, I
Yeah,
mean, there are people who claim to be experts, but are not currently running, a successful backed company. So I wouldn't be too
sure.
much of a caveat there.
Yeah, well, maybe I think we just got lucky with the, meeting some of the right people that have helped us. But I think it's like, yeah, are you doing something innovative on the model side? Like, do you have some innovation on the architecture side? I actually don't really think the whole like data moat is that strong of an argument personally, because there's just so much data on the internet now, and
Data
a
moat
lot
being
of
like we run Gmail, so we can scan everybody's email. That gives us a competitive advantage of knowing
yeah,
something like that.
yeah,
Is that what you mean?
exactly. Yeah, I actually
Okay.
I don't know, like, you might get like a slight advantage, but there's so much data on the internet, and there's so many innovations happening around. Like, look at GPT-3 that OpenAI put out, right? That was just trained on like huge model trained on crazy amounts of public domain data on the internet. Works so well across so many different tasks. So even if you had a data moat for a specific task, like, it's arguable that GPT-3 could beat you at that task. So I think it depends what you're doing, but I don't personally buy into the whole data moat thing that much. Because like even for us, we're able to build some of the best speech to text models in the world, and we don't have this like secret source of data. We just have a lot of innovation on the model side, and there's tons of domain data in the public domain that you can access now. So I think it's really about like, are you building some type of application that is making the lives of like a customer, developer, some startup like easier,
Right.
leveraging AI?
Are you solving a problem
You're
that
solving a
people will pay
problem.
money to
Yeah.
solve? Yeah.
Yeah, exactly. Because I actually think it's more about like the distribution of the tech you're building versus the tech itself.
Mm.
So like, are you packaging it up in an easy to use API, or is like because like, imagine you're selling something to like podcast hosts that uses AI. I mean, the AI could be amazing, but if like the user interface sucks,
Yeah.
like you're
Here's what
not
you
going
do.
to
You're
use
gonna
it.
make a post request over to this, and you put this header in, and like it's gonna like here's how you do paging, and like no, here's the library in your language. You call the one function, things happen, right? Like
Right,
how presentable
right,
or straightforward
right,
do you make it, right?
right. Because I actually think that that's a huge piece of it. Are you making it easier? Are you making um, is the distribution around the technology you're creating like really powerful, and like, do you have good ideas around that? So I think it's a combination of those things. But to be honest, I think it really depends on what you're building and what the product is or what you're doing, because it varies. Like really,
Sure.
it varies a lot. Yeah.
There's also the part that we as developers don't love to think about, but the marketing and awareness and growth and traction, right?
Yeah.
You could say, look, here's the most amazing model we have. Well, we haven't actually got any users yet, but like that is a
Right.
really hard sell for investors unless they absolutely see, this has huge potential, right? But if you're like,
Yeah.
look, we've got this much monthly number of users, and here's the way we're going to start to create a premium offering, and
Yep.
right,
Yep.
that's something we're not particularly skilled at as developers, but that's a non-trivial part of any tech startup, right?
Oh yeah, and I think as a developer too, you kind of like shy away from wanting to work on that because it's so much easier to just write code or build a new feature versus like go solve this hard marketing problem or
Right.
go
But
like
marketing,
write this.
sales, like you've got to have
Yeah.
them, even if you're bad at them and you don't like it.
Yeah. Yeah. We're fortunate that we get to market to developers. So like I enjoy it.
Mhm.
And because you get like to talk to developers all the time. But yeah, that's a huge piece of it too. Definitely. Definitely.
Yeah.
It's got to all come together. Yeah.
All right, let's wrap this up a little bit. We're getting sort of near the end, but let's talk about you've got this idea, you've got your models, you've got your libraries, you've trained them up using your GPUs. Now you want to offer it as an API. Like, how do you go to production with a machine learning model and do something interesting? You want to talk about how that's work? I know you talked a little bit about running the cloud and whatnot, but like,
Yeah.
do you offer it as an API over Flask, or do you run it in
Yeah.
the cloud? Like, what are you doing there? Are they Lambda functions?
Yeah,
What's your
it's a
world
good
look like?
question. So we have asynchronous APIs where you send in an audio file, and then we send you a webhook when it's done processing. And then we have real-time APIs over WebSocket where you're streaming audio and you're getting stuff back over a WebSocket in real time. The real-time stuff's a lot more challenging to build,
I'm sure
but
it is.
the async stuff. Really, what happens is we have so one of our main APIs was built in Tornado. I don't know if you, yeah,
Yeah.
Legacy,
The early async
yeah,
enabled Python web framework before async IO was officially a thing.
yep. So I built the first version of the API in Tornado. So it's kind of like still in Tornado for that reason. A lot of the newer things or newer microservices are built in Fast API or Flask. And so for the asynchronous API, what happens is like you're making a post request. The API is really just like a CRUD app. It's storing a record of the request that you made with all the parameters that you turned on or turn off. And then that goes into a database. Some worker that's like the orchestrator is constantly looking at that database and is like, okay, there's some new work to be done. And then kicks off all these different jobs to all these different microservices, some over queues, some over HTTP, collects everything back, orchestrates like what can be done in parallel, what depends on what to be done first. When that's all done, all the kind of asynchronous like background jobs, the orchestrator pushes the final result back into our primary database, and then that triggers you getting a webhook with the final result. So that's like, in a nutshell, kind of what the architecture looks like for the asynchronous workloads. There's like tons of different microservices, all with different instance types and different like compute requirements, some GPU, some CPU, some, like all different scaling policies. That's really where the hard part is. And that's kind of like the basic overview of how the asynchronous stuff works in production.
Yeah. Very cool.
Yeah.
Are you seeing Postgres or MySQL or something like that?
Postgres for the primary DB. Because we're on AWS, we use DynamoDB for a couple things like ephemeral records we need to keep around for like when you send something in, it goes to DynamoDB, and that's where we like keep track of basically like your request and what parameters you add on and off. And that kicks off a bunch of things. But the primary DB is Postgres. Yeah, I think there's like at this point, like it's getting pretty large. there's like a few billion records in there. Because we process like a couple million audio files a day. with the
Wow.
API. And sometimes I'll read on Hacker News like these I think like GitHub went down at one point because like they couldn't increment the primary key values any higher.
It's
And
Int 64 is overflowing. We're done. Something
yeah.
like that. Yeah.
I'm in the back of my mind like I hope we're thinking about something like that, because that would be really bad if we came up against something like that. Yeah.
Do you store the audio content in the
No.
database, or do they go in like some kind of bucket, some object storage thing?
So we're unique in that we don't store a copy of your audio data for privacy reasons for you. So you send something in, it's a stored ephemerally like in the memory of the machine that's processing your file, and then what's stored is the transcription text encrypted at rest, because you need to be able to make a GET request to the API to fetch it. But then you can follow up with a delete request to permanently delete the transcription text from our database as well. So we try to like keep no record of the data that you're processing, because like we want to be really privacy focused and sensitive. You can like some customers will toggle on that we keep some of their data to continuously improve the models, but by default, we don't store anything.
Yeah, that's really cool.
Yeah.
That's good for privacy. It's also good for you all because there's just less stuff that you have to be nervous about when you're trying to fall asleep. You're like, what if somebody broke in and got all the audio? Oh, wait, we don't have the audio. Okay, so that's not a thing they could get. Like things like that, right?
Yeah. It's definitely. I hadn't thought about that before, but I'm imagining now what that would be.
Well, now now you're gonna be nervous because there's probably other stuff, but that's all good.
Yeah. Now you got me thinking of that in that space. Like, what are those things we need to lock up? Now we have like, we're mostly a team of engineers. So I think of the 30 people, like 70% are engineers, with a lot more experience than me. So we're doing everything like by the book.
Yeah, cool.
Especially with the business that we're in. Yeah.
Yeah, of course.
Yeah.
All right, Dylan, I think we're out of time, if not out of topic. So let's maybe wrap this up a little bit with the final 2 questions and some packages and stuff. So if you're going to work on some Python code, what editor are you using these days?
I'm still using Sublime.
Right on.
The
OG easy ones. I'm mostly PyCharm. If I want to just open a single file and look at it, I'll probably use VS Code for that. That's probably just, I want to open that thing, not have all the project ideas around it. But if I'm doing proper work, probably PyCharm these days.
Yeah, that makes sense.
Yeah, and then notable PyPI projects, some library out there. I mean, you've already talked about it, like TensorFlow and some others, but anything out there you're like, oh, you should definitely check this out.
Let me think. Notable PyPI projects. I would check out Hugging Face if you haven't yet. It's pretty cool library. Yeah, pretty cool library.
Yeah, Hugging Face seems like a really interesting idea. Yeah. I want to give a quick shout out to one as well that I don't know if you've seen this. Have you seen PLS, please, as an LS replacement? Chris May told me about this yesterday. Told me and Brian for Python Bytes. Check this out. So it's a new LS that has like icons and it's all developer focused. So like if you got a virtual environment, it'll show that separately. If you got a Python file, it has a Python icon. The things that appear in the list are controlled somewhat by the git ignore file and other things like that. And you can even do like a more detailed listing where it'll show like the git status of the various files. Isn't that crazy?
That's really cool. Yeah.
So that's really a Python library, PLS.
PLS. That's awesome. I'll check that one out.
Yeah, people would check that out.
Yeah.
All right, Dylan, thank you so much for being on the show. It's really cool to get this look into like running ML stuff. Production and whatnot. You want to give us a final call? Yeah, you bet. You want to give us a final call to action? People are interested in sort of maybe doing an ML startup, or even if they want to do things with Assembly AI.
Yeah. So if you want to check out our APIs for automatic speech to text, you can go to our website, assemblyai.com, get a free API token. You don't have to talk to anyone. You can start playing around. There's a lot of Python code samples that you can grab to get up and running pretty quickly. And then, if you're interested in ML startups, I think that like one of the things that I always recommend is if you want to go like the funding route definitely check out Y Combinator as a place to apply, because that really helped us get off the ground. They
Mm.
help you out with like a lot of credits around GPUs and resources, and it helps a lot. That helped us a lot. So
Were you in the 2017 cohort or
yeah,
something like that?
2017. So
Okay.
was super helpful, and I would highly recommend that. There's also just a big community of other like ML people that you can get access to through that. So that really helped, and I would recommend people check that out.
How about if I don't want to go
Oh,
VC
one
funded?
more.
Oh yeah, go ahead.
Yeah, so one more is there's also like an online accelerator called Pioneer. I don't know if you've heard of this, but that's also a good one to check out too. If you don't want to go the accelerator route, then I would say like yeah, really it's just about getting a model working good enough to like close your first customer, and then just like keep iterating, you know. So like don't get caught up in like reaching state of the art, or uh uh yeah, like in the research, just like kind of think of like the MVP model that you need to build to go win your first customer, and then kind of keep going from there.
Yeah, awesome. All right, well, thanks for sharing all your experience and for being here.
Yeah, thanks for having me on. This was fun.
Yeah, you bet it was.
Cool.
Bye.